Hello Year 5, I hope everyone is fine. Welcome back to my channel. Today we are going to start a new topic. As you can see, there's a gigantic magnet behind me in the picture. But I have a similar one here in the classroom. We are going to name this magnet. It has a U shape, so you can call it U-shaped magnet or a horseshoe magnet. That name is often used as well. So this magnet can attract other magnets, of course, like this, attracts the magnet. But what happens when I'm going to use the bar magnets and I put together the two poles? Can you remember the names of the two poles? The red one is the north pole of the magnet, the blue one is the south pole. So if there are different poles right next to each other, they can attract each other. But if the poles are the same, like now we have the two south poles, it's really hard to push them against each other because they repel. So attract, repel. Yeah, these are the two special forces you need to remember. What happens if there's a special metal object like steel? Is it magnetic? Let's see. I have the U-shaped magnet, and yeah, it can attract it, so it's magnetic. What happens if I place this paper clip in a special beaker? Can the magnetic force work even if the object is underwater? Let's see. I hope you can see that the paper clip can move, and I can even pick it like this. I can take it out of the water. Is the key magnetic? Definitely not this kind of little plastic thing attached to it, but the key is magnetic as well. Or I have a little padlock which we use on our mobile phone cupboard, and look, this is magnetic as well. Okay, then let's see what we mentioned so far. So what is a magnet? A magnet is an object made of metal which attracts other metal objects that contain iron or other metals such as steel or nickel. Around the magnet is a special magnetic field where the magnetic force is felt. The magnetic force is called magnetism. So the magnetic force is all around the magnet, around the poles. What happens if I cut this magnet in half? Will it be still magnetic? Will it have two poles? Yes, no matter how many times we cut the magnet in half. Again, there's going to be a north pole and the south pole, and we can never change that thing. Which word is mágneses erőtér? Magnetic force, right. Attraction, repelling. All magnets have a north pole and a south pole. If two of these same poles are put together, they will push each other away, they will repel. If opposite poles are put together, they will pull together, they will attract. This is called magnetic interaction. You can see the drawings here. I would like you to open your exercise book now, write the title, Magnetic Force, and the date, 23rd of March, and copy these sections. You can stop the video, copy the important thing, draw the horseshoe magnet or U-shaped magnet, and then move on. When you finish this one, please write this down. And I also need the drawings. So you can stop the video, write these. When the two magnets repel, it should be symbolized like these two south poles or two north poles close to each other. When they stick together, they attract north and the south pole. So please draw this in a similar fashion. If you finished it, then the repulsive magnetic force is symbolized here as well. But look at the different types of magnets we can see around us. There are U-shaped magnets and horseshoe magnets here. The cylindrical magnet is there in the middle, a bar magnet, similar to this one, and ring magnet, button magnet. Magnets are used around your house as well. Sometimes, if you have kitchen cabinets with magnets in them, you know, the doors can kind of attract each other. So this way, it's safer to close them. Or for instance, at home, I have a dishwasher where the door has a special kind of magnetic frame. So when I close the door is attracted onto the base or towards the base of the dishwasher itself, so water cannot leave the machine. So that's it. This will be a nice background image for us now for a second, because I would like you to see something different as well. There are certain objects which are not magnetic at all. I found this ruler in our classroom. I hope you didn't lose it. And if I have tiny pieces of paper tissue in my hand like this, you could just think that, oh, these are not magnets, they cannot really attract each other. But if I have a special trick and I start rubbing the ruler against a piece of textile, especially polyester, this is why I placed here one part of our sofa from outside. So actually I just rub the ruler against the surface of this. I hope we can do something special now. Look, the ruler can attract the tiny pieces of paper tissue. How is that possible? Actually, we can read about that thing. I'm just going to close this part now, and we need to have another kind of image. Just a second. Yes. So, if you look at this picture, you can see that even in a simple object like this ruler, or if you have a glass tube, there are different particles, and these tiny particles can be charged, either positive or negative. And if the positively charged particles meet some negative charges, then they can attract each other. This happened in a special experiment. So let's read about this now. Please open your book. At this part here, it's page 78 in your book, this one. And we are up here. So, you can follow this with me. Sometimes if you wrap a balloon to your hair, they stick together. All matter has bits of electricity that can cause this sticky feeling. Particles in objects are charged electrically. They usually have positive and negative charges. Matter that is charged electrically has a special electric field around it. You can also experience electric charges of matter if you go down on a slide, and then when you touch another person, he or she might get a little electric shock. It is not dangerous, of course. Sometimes electric charges can jump between objects as positive and negative charges attract each other. Similar to the magnet, only unlike charges will attract each other, like charges will repel each other. This is called electrostatic interaction. Okay, now I would like you to have a look at the keywords as well and read them with me. They are on page 79. So, attract, vonz. Cardinal direction, fővilágtáj. Compass, iránytű. Effect, hatás. Electric charge, elektromos töltés. Electric field, elektromos mező. Electric shock, áramütés. Face, előlap. Interaction, kölcsönhatás. Intermediate direction, mellékvilágtáj. Like northeast, southwest, such things. Like charges, azonos töltések. Magnet, mágnes. Magnetic field, mágneses mező. Magnetic force, mágneses erő. Magnetic pole, mágneses pólus. Magnetism, mágnesesség. Needle, tű. Repel, repulse, taszítás. Rub, megdörzsöl. Slide, csúszda. Unlike charges, ellentétes töltések. Okay, now I would like you to stop the video and write down the words in your exercise book under the other parts which we started about magnetism. So page 79, write all the words there. Okay, and after these parts, some of the images can be analyzed in the book as well. What can you see there? Yeah, a magnet. The North Pole and the South Pole are symbolized. And where can you find a gigantic magnet? Yeah, in the Earth. And with a compass, you can just check that. Because the big magnet in the Earth and this magnetic needle here attract each other. This is why the needle starts moving around and it shows you the cardinal points. North, south, east and west. And of course there are the other parts here, symbolize that, the intermediate directions, northeast, southeast, southwest, northwest. So which direction is this one? Northeast. And this one? Southwest. And this one? Northwest. And this one? Southeast. Good. Now I would like you to work in your workbook. Please open your workbook at page 72, so this part here, and work on the task. Of course, you can use the book to help you on page 77, this one, page 77. So stop the video and write there the answers. Then, let's see what we have here. Around the magnet, there's a special magnetic field. Sorry, my writing is not the best here because it's not that simple to write with this special pen, where the magnetic what can be felt. We mentioned that earlier, force is felt. Okay, when a magnet other objects, it has an effect on that object. So what can the magnet do? It can attract, or what's the other one? Repel. The of a compass always points to the Earth's what? So, if you check the book, it will show you that the needle of a compass always points to the Earth's magnetic poles. Magnetic poles. There are two poles on the Earth. The north, symbolized by red, and south, symbolized by blue. In objects are charged. What are charged in objects? What were these tiny parts here in a ruler or in this special glass rod? Yeah, the particles. Particles is essentially. In objects are charged. How? They are charged electrically. This is what we had in our experiment. Electrically. Sometimes electric charges can jump between objects. So this could be seen here when I made this special experiment with the ruler. So if you finished working here in the workbook, you have the special thing in your exercise book as well, then you completed this task. Of course, you can just check many other things about magnets and electricity, and the homework task is the following one, page 71, task 1, and task 2. So page 71, I'm trying to hold it like this so you can see the page number. So page 71, task 1 and 2. And later on, we can check this homework task. So, learn a lot. After that, you can relax, keep up good work. Bye-bye.